Hi Bobby, this is section 8.7, problem 7. So if we have, they give you the limit of x approaches 6 of square root of x plus 10 minus 4 over x minus 6. Okay, if you find the limit by replace x by 6, you will see that 6 minus 6 give you 0, which is undefined. Then in the chapter 1 through 3, we study to solve this one by cross out the causing guy, the guy who caused the problem. So I try to do is cross out x minus 6. So we have to do is multiply the top and bottom by the conjugate of square root of x plus 10 minus 4. So the conjugate is x plus 10 plus 4 for top and bottom. Again, I'm solving for problem A, which we use the material in chapter 1 through 3. So when I multiply top and bottom for the conjugate, on the top will be the limit of x approaches 6. Since this one is a minus b time with a plus b, then I can apply the difference of cube. We will have the first term square root of x plus 10 squared minus the second term square, which is 4 squared. At the bottom, I just go ahead, keep whatever I have, x minus 6 times with square root of x plus 10 plus 4. Okay, let's extend this one a little bit further. So then work out on the top and see what do I have. The limit of x approaches 6. On the top, the square and square root will be cancelled off. Give me x plus 10 minus 4 squared is 16. And at the bottom, we have x minus 6 times with square root of x plus 10 plus 4. Okay. Then I simplify the top, combine like term. So x minus 6, and the bottom will be x minus 6 times with square root of x plus 10 plus 4. So as we see that x minus 6 like terms, we'll go ahead cross them out. Give me the limit of x approaches 6 of 1 over square root of x plus 10 plus 4. Okay, since the guy who caused problem right here has been cancelled out, so now the problem go back to the regular. You can replace x by 6. Then I have 1 over square root of 6 plus 10 plus 4, which give me 1 over square root of 16 plus 4, which give me 1 over 4 plus 4, which is 1/8. Okay, the way we solve on this problem is the material from chapter 1 through 3. So in the next one, I'm going to show you how to solve the problem by L'Hopital rule. Okay, in problem B, we start to solve this one by L'Hopital rule. So by substitution, when I plug it in, we will see that the limit x approaches 6 of 6 plus 10 minus 4 over 6 minus 6, which is square root of 6 plus 10 is square root of 16, which is 4 minus 4. We will have 0 over 0. So then because it's 0 over 0, you can apply the L'Hopital rule. So I will do it, take the derivative on the top and take derivative at the bottom. This one is x plus 10 raised to the 1/2. So when we take derivative, you will have 1/2 of x plus 10 raised to the negative 1/2. And derivative of 4 is 0. At the bottom, you will have derivative of x is 1, derivative of 6 is 0. Okay. Since this one is negative exponent, I can bring it down as the limit of x approaches 6 of 1 over 2 x plus 10 raised to the 1/2. Then we can do is substitute x by 6, plug in 6 as at the x place. So we have 1 over 2. 1/2 will be square root of 6 plus 10, which is the limit of x approaches 6. 1 over 2 times square root of 16, which is 1 over 2 times 4, which is 1/8. And it's matched with the answer we have before. Okay, in problem 36, we have the limit of x approaches infinity of ln x to the 4 divided by x to the third. So by direct substitution, we will have the limit of x approaches infinity of ln infinity raised to the 4 over infinity raised to the third was equal to infinity over infinity. Since it's one of the form, we can apply the L'Hopital rule. So I'm go ahead to apply the L'Hopital rule. Come on, L'Hopital rule. So I will take the derivative on the top and also take the derivative at the bottom. Before I do that, I can apply the power rule of the logarithm by bringing 4 in the front to make my problem easier. So we will have 4 times with ln x over x to the third. That will be equal to the limit of x to positive infinity. 4 derivative of ln x is 1 over x, and the derivative of x to the third is 3x squared. So this problem can be rewrite as limit of x to positive infinity of 4/3 time with this x can go down as x to the third. Let's rewrite this nicely. So we have limit of x approaches infinity of 4 over 3 x to the third. Then I will do is substitute x by positive infinity. That will give me 4 over 3 of infinity raised to the third power. So that will be 4 over positive infinity, which is equal to 0. Problem 53, we have the limit of x approaches 0 from the right of x plus 1 plus x raised to 1 over x. So by direct substitution, we will have 1 plus 0 raised to 1 over 0. So 1 over 0 is, if we graph them out, you will have the graph look like this. So when it's 1 over 0 and it approaches from the positive side, so they will approach us from the right, so it's go to positive infinitive, and that form will be equal to 1 raised to positive infinitive. That is one of the form we can apply the L'Hopital rule. So I will go ahead and apply the L'Hopital rule for this. Apply hospital rule. What's wrong? So before we do this, since it's in the form 1 over infinitive, or if you see the case where it's 0 raised to the 0, 0 raised to 0, both of them they solve by the same concept, by let y equal limit of limit of x approaches 0 on the positive side, 1 plus x raised to 1 over x. Then you will do is natural log both sides. Ln y equal ln of the limit x approaches 0 positive side of 1 plus x of 1 over x. Then this one will be equal, since the limit, like the sigma, so you can put the limit outside and the logarithm stay inside, of 1 plus x raised to 1 over x. Then we have to how can I say, use the power rule, bring the exponent 1 over x to the front of the logarithm. That will give me the limit of x approaches 0 from the positive side of 1 over x of the logarithm 1 plus x, like this. Then we will do is take the derivative on the top and derivative on the bottom. So that's equal the limit of x approaches 0 from the positive side. So the limit on the top, the limit of the logarithm, will be 1 over 1 plus x over the limit at the bottom where is x is will be 1. So which can also be rewrite as the limit of x approaches 0 positive side of 1 over 1 plus x. Then we can go ahead plug in 0 into the x place. That will give me 1 over 1 plus 0, which is 1 over 1, which is 1. Then the problem is not done yet, because the last time we let y equal to the limit and we do ln both sides. So the one right here will be equal to ln y equal to 1. And since y ln is the logarithm base e, let me choose the different colors so we can see it easier. Yellow. Ln y is the logarithm base e of y equal to 1. Then I can do is move the base to get y by itself. When you move it over, that will push the 1 go up. Then we will have y equal e raised to the first power, and that is the answer. Y equal e to the first power. This problem 61, the limit of x approaches 1 from the right of 3 over ln x minus 2 over x minus 1. if I use the direct substitution, you will have 3 over ln x ln 1 minus 2 over 1 minus 1. So with this one, we will have 3 over 0 and minus 2 over what is it? 0. Okay, since they all both of them over 0, and we approach this one from the right, so you will have the infinity that will be equal infinity minus infinity. That is one of the form to apply the L'Hopital rule. So I'm going to do is apply the L'Hopital rule. So before we do that, I have to rewrite 2 logarithm in term of 1, 2 fraction in term of 1 positive. So we have 3 over ln x minus 2 over x minus 1. Okay, so my LCD is x minus 1 times ln x. So I multiply the first fraction by x minus 1, the second fraction by ln x. And I will have, that is the limit of x approaches 1 positive of, I also distribute 3 of 3x minus 3 minus 2 ln x over x minus 1 times ln x. Okay, that will give me, if right now I take the derivative on the top and the bottom, we will have derivative on the top with a 3, negative 3 will turn out 0, and minus 2 ln x will be negative 2 times with 1 over x. The derivative of this one, I have to use the product rule. So derivative of the first term was this 1 times with ln x plus derivative, so you just take derivative of x minus 1, so right now x minus 1 stay the same, and ln x will be 1 over x, okay, which can be also rewrite as limit of x approaches 1 positive. This one, if I multiply the top and bottom, actually outer term by x, this one by x is the complex fraction, this by x, this by x, and this by x, I will have 3x minus 2, this will be cancelled out, of over x ln x. This cancel out, give me plus x minus 1. Okay. What else can I do? Okay, if I plug in 1 right now, so what do we have? We will have 3 times 1 minus 2 over 1 times ln 1 plus 1 minus 1. So we will have 1 over ln 1 is 0 plus 0, you have 1 over 0. 1 over 0. But as we know that 1 over 0, the graph is above like this, and it approaches from the right, so that will go to positive infinity. That's equal to positive infinity.